Yes, good evening, everyone. Welcome to the third lecture in the second block. Let me give a short introduction. Every one of us uses Google or one of the other search engines most days in his life. And I believe no one of us has ever thought about what can be made out of the search queries you enter there, what any adversary or any honest company, I suppose they exist, can do with them. Now, today with us is Robert, and he's been doing some statistical analysis of some search queries. Well, some in this case means 34 millions. And yeah, he's going to give us a brief talk about what you can do in terms of profile building out of them. Enjoy.
Well, thank you. I actually expected less people here because there's a so-called alpha meeting in parallel, but well, it's fine for me, so it seems that you're really interested in the topic. Well, the talk is named Mining Search Queries and is basically about finding interesting additional knowledge in search query logs. In particular, I focus on the AOL dataset of search queries, which was released in, well, 2006 and is reasonably big for that purpose. So this is the agenda for the talk. First, I will introduce you to the AOL dataset, to the origin and to the aftermath of the publication. Then I will give you a short introduction to data mining, just a definition. Then we will go into detail with the general statistics of the data set. I will tell you what search trend mining is, and I will show you some, well, interesting queries which really change significantly over time. And, well, probably the most interesting part for you, user categorization and identification, well, which is basically classifying users into some categories or even identifying users only by their search queries. Well, and at the end I will summarize the whole talk. Okay, this is basically the timeline of the publication. I tried to reconstruct it. At the end of July, AOL intentionally published some real-world search query logs from their AOL search engine. Well, it is reasonably big. It is about 37 million records and around, well, 600,000 users. Well, and soon after the publication, AOL received some serious negative feedback from the media because, well, despite anonymization of the data set, there is still lots of private information in those queries. So AOL was forced to take the data offline, and even a public excuse did not relax the situation because, well, the web never forgets. The data set was soon mirrored all over the internet and is still available. So as a consequence, the responsible researchers got dismissed. I think, well, 3 persons had to leave the company. And, well, furthermore, AOL got sued multiple times by their own users for the publication of their private search queries. This is basically the timeline, but I want to focus on the data set itself in this talk. So, well, this is the URL where you can download the data set. It links some mirrors of the data. The zip version is about half a gigabyte. You simply download it and, well, unzip it. Then you have the full text version, which is around 2 gigabyte, so not so big. It contains about 36 million records. These are single search queries, but only 34 million unique ones. So there are some duplicates. Duplicates are search queries with the same time, the same query content, and submitted by the same users. I assume that those queries are neglectable. Okay, what you do is you would, import the data in your favorite database system. This is just the format of the data. We have 36 million records of this format. I took 2 samples here. This is basically tab delimited data. The first attribute is an anonymous user ID where, well, AOL substituted the username, the AOL screen name, with an anonymous ID. Then we of course have the query content, which was typed into the search bar. And we have the time stamp when the query was submitted. And the last 2 attributes are optional. In case the user clicked on a search result, the rank of the result and the domain part of the clicked URL is listed. So this is basically the structure. So, and well, AOL thought that this data is anonymized, but we will see actually it is not. What do we want to do with that data? We want to do some data mining, finding some interesting knowledge on it. But what is data mining? In my eyes, data mining is the systematic extraction of significant patterns and valid, novel, formerly unknown, potentially useful knowledge. Usually in large data sets, because, well, otherwise it makes less sense. And you usually use statistical methods and, well, data mining techniques. This is, the next slide is, well, a very common knowledge discovery procedure. You usually start with flat files containing the records. Then you apply a so-called ETL process on the files. ETL means extraction, transformation, loading. Well, extraction could be that you select the attributes which you'd like to import in your database. Transformation might be that you have to convert some values in the data set so that it fits into your database schema. Well, and loading is simply the database import. This all ends up with a working copy of the data in your database, sometimes with metadata. Well, and before you start to apply your statistical analysis and data mining algorithms, you usually select subsets of the data in data mods, which are, well, some kind of views on your data. Furthermore, you usually create some indices on the data because, well, to speed up things. And then it is possible to, well, derive statistics, derive reports, or derive even models of your data. The whole thing ends up with some human interaction where the knowledge is interpreted. So if you want to make a decision out of the data, you always have some human factor. Okay. So let's go into detail with the statistical analysis. This is what you will see in the next slides. Basically, we go through all dimensions of the data. We look at the distribution by time, by query, by user, and by item rank. Well, let's see. The first plot is basically the frequency plot of the overall data. It is, well, you can see it is over a period of 3 months. Well, it starts pretty perfect. You can even see some weekly cycles, but then there is a decrease, and well, and suddenly there is a sudden decline. It is on May the 16th, I think, where, well, where the query frequency declines enormously. We will see that this results in some problems in our later analysis. Okay, but this plot is pretty perfect. It is the frequency plot by hour of day. You might have seen it before in your own web server logs, that, well, the query frequency is not the same, is not equally distributed over the day. The minimum is, of course, in the nighttime hours, and there is a certain increase during the office hours, and the maximum is reached, well, early evening hours, I would say. Well, this one is pretty perfect in my eyes. Well, things seem to be simple, but if you go into detail, they are not. What I did here is I plotted the difference to the hourly frequency mean of some selected queries. Well, basically this should end up into a straight line if all queries were equally distributed, but they are not. So values above 0 mean that this query is overrepresented in that hour, and values below 0 mean that this query is underrepresented. And what you see is, well, the query for adult entertainment is overrepresented in the nighttime hours and, well, underrepresented in the afternoon, I would say. Whereas the query for the Bank of America, well, people are doing their online banking or whatever, is overrepresented in the office hours. Well, and what else do we have? Oprah, which is a very popular talk show in the United States. And Oprah has a peak, well, at 17 o'clock, I would say. Well, and I would bet my ass that this is the broadcasting time of the TV show. So you can investigate in that. Okay, the next plot is the frequency distribution by the user ID. So you can see that we have basically 600,000 distinct user IDs. Be careful with the y-axis. The y-axis is log scale. This will happen very, very often in the next slide, so be aware of it. That basically means that the distance on the y-axis is actually much larger than it appears. Well, and what you notice is that the largest portion of users submit only very few queries, and the smallest portion of the user submits the largest portion of the queries. Actually, there's one user ID submitting 250,000 queries. Well, and at the beginning I thought, well, what's that? Maybe a bot or a script crawling AOL. But it turns out, well, if you look at the query distribution of that user, this user is searching for all kinds of topics, and it's searching all the time, daytime, nighttime, day by day, sessions in parallel. So this might be an account with multiple users. Now, at the moment, I assume that this is the guest account from AOL. Well, this would be my interpretation. Here I plotted the click-through by the item rank. So, well, obviously it's clear that if you have a higher rank on the result page, you receive more hits. Again, this is log scaled. Well, and we can go into detail because this might be interesting. You can even see, if you plot only the first 100 items, that, well, there is a small peak at the end of the result page. That means that the last result on the page is, well, maybe receives a little bit more hits than the result before. And this is the plot of the first 10 ranks. So basically meaning that this is the first result page. And this is not log scaled, so that you can see that actually rank 1 receives by distinct the most hits, while actually, well, the click-through rate triples. So this has certain implications for the so-called search engine optimization. Of course, everybody is keen on getting rank 1, but now it's obvious why, because getting from rank 3 to rank 1 not even doubles your click-through, but getting from rank 2 to rank 1 triples your click-through rate. So it's clear why everybody is keen on rank 1. And well, you can also state that holding a result with rank modulo number of results per page equally to 0 or to 1, which means that you have the first result on the page or that you have the last result on the page, is even slightly better than holding a higher rank. Well, what else is interesting? If you hold the last possible result, which means in our case rank 500, so it is the last result on the last page, this actually receives a lot of hits, more hits than any rank below 270. So, well, if you can't go for rank 1, go for rank 500. Okay, now we'll go into the actual analysis of the query content itself. We'll look at the distribution of the queries. We'll look at, well, the topic. We will look at the statistical of the pie chart of the topic categories, and well, maybe we can differ. Maybe we can find some geographical locality in the queries. Okay. To give you a first impression, this is the list of the top-rated queries by frequency. Well, okay. Google, eBay, Yahoo, no surprise, because these are very popular services. This one is the empty query. What is really funny for me is that people are looking for the term internet. Well, I was not sure why this happens, because maybe they are searching the internet, they are not aware of the fact that they are actually in the internet. I'm not sure. Well, maybe this is due to the AOL users, but what else is interesting? People are looking for URLs, for full URLs. So the question is, why are they searching for URLs they actually know? Why do they type them in the search bar instead of typing them in the address bar? So, well, there's a number of possible explanations. Of course, you might want to use the search engine cache, or you might want to use the translate button, or you might want to find related sites. Well, but I don't believe that, well, you don't want to translate Google or something like that. Maybe it's due to the fact that these are beginners and they are not aware of the difference between the search bar and the address bar. They use it maybe for the same purpose. Okay. This is a plot where I plotted the frequency of the query by the actual query rank. And both scales are log scaled. And if that results into a straight line, we call that Zipf's law. Well, so search query meets Zipf's law, which is basically a very popular power law in the computational linguistics. And it basically means that the query rank divided through the frequency of the query is more or less a constant. It's had certain implications for, well, maybe search engine caching or the search itself. but we don't want to go into detail with this. What else is interesting? The average query length by terms is only 2.5 terms, which is actually more than I expected, but it is too less to find appropriate results. So if you only enter 2 terms and you hope to find the right site, well, in some cases it might be if you look for Google or what, but in other cases it might not be appropriate. What is important is that the character set of the queries is some kind of messed up by AOL. They removed slashes, they removed columns, the percent sign, and the quotation marks, and this has some implications for our later analysis, so just keep that in mind. Okay, we're not only interested in the frequency of a single query, we are interested in the frequency distribution of topics. So the question is, how can I detect the topic of a query? There are a number of possible solutions. I have chosen a very simple one, which I call the DEMOS solution. If you want to determine the topic of a query, you look up the URL in which the user clicked in the DEMOS directory, and you take the URL in which, you take the topic category of the URL in the DEMOS directory as topic for the search query. Well, and then you count the matches for each topic category, and this is the result. Of course, regional queries are some kind of overrepresented. You will see later on that these are regional queries for North America. Then we have computers, shopping, business. What is some kind of surprising that the topic category adult entertainment has only 1.5%, which seems pretty low for me. But this is, you can imagine why. Because maybe not every porn URL is listed in the DEMOS directory. So what are the pros and cons of this solution? Well, of course, the pros are this is very quick solution. It delivers comparable results. But the contra is that you are bound to the topic categories of DEMOS. So there are much more sophisticated approaches possible. Well, you can think of unsupervised clustering of search queries where you cluster the terms by some collocation measure and you get a much more natural motivation for topic categories. But then you run into other problems, and so I did not show that here. Well, okay, again, queries with original character are overrepresented. What else can we do? We can differ between local and global queries. Local queries are queries containing a reference to some kind of local aspect, so maybe city names, county names, state names, country names. And what I did is basically plotting the regional aspects, so localized queries, in this case by state. The darker the color, the more this region is represented in the queries. So the top rated areas are, Florida, Texas, New York, California. But what is even more interesting that if you plot this on the country level, you could even see the origin of the data. Okay, we did that, we knew that before, but if we wouldn't, we could notice it here. So queries with relation to the region United States are overrepresented. A bit Mexico, a bit Canada. Well, can you see it? No, actually not so perfect. A bit India, a bit China, and a bit Russia. But sorry, folks, Germany is, quite underrepresented. So this is one thing you could do. Let me introduce you to the area of search trend mining. So questions might appear, do queries change over time, or are they equally distributed? Do queries correlate with current events of times? What queries do change most? And so you have to develop a methodology for investigating in those areas. Well, you basically do a time slicing on the data set, where you split the data set into k equally sized partitions, and then identify the queries which with the largest growth rate over 2 consecutive slices. So these are the first results. What I did is with a k of 92, which basically means that each slice is a day. And these are the top rated queries to this interestingness measure, which is basically the difference between the frequency in the consecutive slices. The results are quite suspicious because there are many top rated queries in the list, and the slice where the significant growth takes place is sometimes the same. So I investigated in this, I plotted the top rated queries, and well, usually they should not change much, but this is the problem. This is the sudden decline which you saw before, and which disturbs our search trend mining algorithm. So because this is a very sudden increase. So the only solution that I saw is manual filtering the suspicious slices and the top rated queries and ORLs. But if you do that, you get really some lists of interesting queries which do change significantly over time. We will look onto that now. This is the area of entertainment queries, where, well, people are looking for maybe the Country Music Awards, Deal or No Deal, American Idol, or the Oscar winners. And, well, what you see is the red line is the Country Music Awards, and the increase of the query frequency strongly, tightly correlates with the broadcast of the Country Music Awards in TV. So the same for the Academy Awards here. And well, and you can even see some cyclic TV shows, Deal or No Deal, which is some kind of quiz show, and well, American Idol, which is the equivalent to the German pop stars show, I think. Well, you can see some kind of weekly broadcasting cycle. So at least these queries correlate with the actual event in the real world. We can do that for all other kinds of people in the list. This example is for person names, where you can find Whitney Houston is very often looked for during, well, she had a period where she was fighting her drug addiction, and this was all over the media. This is Laura Welch Bush, which visited the American troops on the 1st of May in Afghanistan, I think. So this is this sudden increase. And you could, well, develop that further. There are even some correlation with public holidays. People are searching for, well, Easter, of course, on Easter Sunday. Well, this has certain implications. You can optimize maybe your Google AdWords campaign to that or whatever. This one is Ash Wednesday, the green line. Here's the Memorial Day. And well, where is Mother's Day? People are actually looking for Mother Day poems and Mother Day gifts just on Mother Day. Okay, this is the summary for search trend mining. Well, we noticed that search queries actually correlate with current events of time. what is important is the window size of the slices, because if you increase the window size, you can even, well, see some long-term tendencies. I did that here. This is the window size, well, one slice is 1 week, I think. And I plotted the queries swimwear, outer furniture, and spring break. And it's obvious that, well, the spring break query is overrepresented in the springtime, and people are looking for outer furniture at the beginning of the summer. So you could do that. So, but overall, it's a sensitive measure for the interestingness of a query is essential. But I showed you one. So now the maybe most important part, user profiling. We want to generate user profiles out of search queries. We want to tag user IDs with attributes. You can do that manually or automated. There are even some projects in the web which do that manually, where you tag some user IDs with the keywords of the search. But, well, this was too much for me. I like it the automated way. So you could categorize users into some categories by their usage frequency, by their interests, and even by their competencies. We did that we did the user interest profile already, because we can detect the topic, and so we could attribute the user ID with topics he is looking for. But you could also introduce some categories for the usage frequency. You could introduce frequent user, average user, and infrequent user. You could differ between weekend and weekday user, and you could differ between daytime and nighttime user. And basically it shows that, AOL search engine users seem to use the search engine, mostly infrequent or average. Mostly search all over the week, but there are some users which only surf on weekends. And that AOL users, mostly search on daytime or mixed. Only 5% of the users are only submitting queries in the nighttime. Well, you could interpret this as some kind of nerd factor or what. What else could you do? Sorry, I did not understand. The numbers you plus
100%. Questions, please. Questions, please, on the end, and please raise your hand and wait for the microphone. Thank you.
Okay, we will go into detail later. What else could you do? You could differ between beginners and expert users. How would you measure the competency of a user? You could measure the usage of some expert search features, which are, for example, exclusion or alternatives, which are quotation marks or certain restrictions on the query. But it turns out that on this data set we cannot investigate in detail, because AOL filtered some characters, so we cannot. I cannot give you some numbers here. You could grab for in URL, in title, in text. And surprisingly low. Only 17 users at all are using such special features. Okay, what else could we do? We could try to identify the individual which is behind a certain query set. You could do that by IP addresses, by authentication information, but we do not have this information in the data set. So the only thing which we could focus on is to localize possible primary keys in the query history of the user. So the precondition is that users are actually searching for keys of themselves. For now, I neglect the fact that users are also searching for keys for people they know. This leads to some false positives. I will show you that later. As some possible primary keys are, you could look for are the social security numbers, credit card data, driver's license numbers, maybe full names with address data. You could look for telephone numbers. You could look for email addresses. The problem is that the key found actually correlates to the user who entered the query. This is not sure. This is not for sure. Another problem is if one account is used by multiple users, this results into some aggregated profiles where you find multiple keys in one query set. So this is also a problem. I did that for some possible primary keys. Here the social security number, which has a certain format. Basically a number split in 3 parts, consisting of an area number of a predefined set, a group number, and a serial number. These are the results. There are queries with real social security numbers in the data, but you cannot be sure if that social security number actually belongs to the user who submitted it. These are false positives. Find Robert Williams or locate Kate Evan Thompson. So probably this is not the user who submitted the query. You could look for personal names. There are a lot of possible approaches to identify personal names in queries. For example, one sophisticated approach is named entity tagging, but what I did here is I used very large list of first names and last names. This is sufficient for the first try. It turns out that the results are very unspecific. There are a lot of false positives in the data, so you have to add some extra context to the name. For example, if you add the pattern, my name is, I am, whatever, you can reduce the false positives and people seem to talk with a search engine. So you find some true positives with, for example, this one, hi, my name is Amy Bruce, I'm 7 years old. Or this one, my name is James Marvin Sparks Jr., how many more of the Sparks are in Florida? There are also some false positives. I think Alan Ray is a famous basketball player, and Joel Santana is also some kind of celebrity. But, this is, a good approach for identifying users. The next approach is looking for telephone numbers. We have the North American numbering plan, which follows a regular expression, so you can grab for some queries containing telephone numbers. There are, of course, some other numbering schemas, but this one is sufficient now. And you look for telephones, and you find some true positives. I was cut off from the tech support, have them call me back at 123 blah. I want to know if there are charges for my dial-up number, 706, whatever. This my is an indicator that this number actually belongs to the user who submitted the query. And what you would do is, you would basically look up the telephone number by reverse search in some telephone directories to identify name and addresses, and so you have an identification of that user. There are also some false positives. Probably this one is a false positive. I am a police officer. I need the address from 123. I'm not sure if this query submitted is actually police officer. By these kinds of techniques, it is possible to identify users. I'm not the first one investigating this area. The New York Times identified user 4417749, which is Thelma Arnold, a 62-year-old widow, which lives in Gilburn, Georgia. They published a photo of her. And how they did it, they looked at the queries of her, and they found a lot of searches for the family name Arnold. And Thelma Arnold was looking for homes sold in Lilburn, Georgia, or homes sold in Gwinnett County, Georgia. Well, and this led to the identification of this user. And I'm sure you believe me that you could identify more user IDs in the data. Let's go into some further thoughts, because the data is quite incomplete. The IP address is missing, the query history is only over a period of 3 months. There is no explicit user data in the data set. But imagine what is possible for those with the real data, because they have really long-term profiles. The Google cookie expires in 2038, and they do not even need to mine for your name or address. Sometimes they may have it already, because if you are registered for another service of the same company requiring name and address, they simply have to join the data, and so they can, well, correlate your search queries with your name and address. This is quite frightening, so we can think of some consequences of this incident for your searching behavior. You should generally adapt your searching behavior to avoid those kind of data aggregation and user profiling. I'm not sure if we will ever see again such an incident, but, well, just in case. Well, you should at least clean your cookies regularly, so to avoid data aggregation. You should avoid being trackable by your IP address, because IP address correlates somehow to location, and, well, location somehow correlates maybe to user. It's never a bad idea to anonymize. You should avoid personalized queries. I know this is some kind of difficult, but, well, you should try it. And you should boycott monopolies, because, well, if you use all kinds of services from the same company, well, it is very dangerous, because they are able to join the statistics and the data sets, and this is even more powerful. Okay, let's summarize the whole thing. You've learned that search queries are actually private data, although AOL thought that the data was anonymized. We have seen that a broad range of knowledge can be mined out of the data despite the anonymization. Well, I could not show you all details, because, well, I thought I have not enough time, but, well, we can go into detail later. We saw that user identification is possible. Of course, IP addresses and long-term profiles would make things much easier, but still it is possible. And, well, you should adapt your searching behavior accordingly, so you should derive some consequences for your searching behavior. Well, that's it. There are questions or remarks. Well, maybe it's now the time.
Yes, we have a lot of time for some questions. If you have a question, please raise your hand and wait for the microphone. Any question?
Do you know how much of the queries are not included in your categorization chart, so where you couldn't find the matching URLs in DMOS?
Well, I could look that up, but at the moment I'm not aware of the number.
Did you do any research about email addresses?
Email addresses? What kind of email?
If people search for email addresses.
Email addresses?
Yeah.
I understood evil addresses.
Well, would be kind of the same.
Well, people are searching for email addresses, but again, the problem is, does the email address correlate to the user who submitted the query? Or are they looking for people they know by the email address? There are other keys which are probably more valuable than email addresses. You can find a lot of email addresses in the data. Well, I showed you the data set. You can investigate yourself. It's no problem.
And another question, if I may, did you find an explanation for the down peak, for the explicitly down peak?
Do you have one?
No. I mean, maybe it's an
Well,
American thing or so.
I looked up, I was searching for some, well, maybe power failure or whatever, but I could not find anything in Wikipedia or something like that. I assume that this is just during the compilation of the data set, because this is not the full data set of the submitted queries over that time. This is only about 0.3%, I believe. So I think this happened during the compilation of the data set.
Thank you.
I believe that hole from the data set is because it came from one of their search machines, not from all of their search machines. That's my understanding of that hole. My observation was that we are looking here at the personal information of people that we don't know, and so we don't really care about that. The place where I am most concerned is in the proxy logs of companies, where the people who run those machines are people that you do know, and they have access to exactly similar kinds of information, except they also employ you, and so they have considerable power over you. And that is a place where I think this kind of audience should be taking these observations away and encouraging the firms where they work from to be much more open about their own corporate policies for data retention of these things. And so that's less of a question and more of a, I hope you see the same point.
Well, very good remark, indeed.
I just wanted to add that I personally am responsible for the logs of a large company, and after looking at the data in much the same way as you have, but in much less detail, I changed the policy at my organization to shorten the period over which we keep logs to that merely which will help the systems managers detect problems and so on.
Okay, fine.
Any more questions?
One more question? Okay.
Can you tell from the data how many users are actual AOL users and how many of those are...
I can't tell you, but well, this is the data of the AOL searching engine, which is probably used on the starting page of AOL. So, well, I would never use the AOL search engine if I'm not an AOL customer. So probably most part of the users are real AOL users.
Yes, because I think most AOL users use the same proxy servers when they are logged in. So this might be an explanation for the few IP addresses which produce more than 1 million of requests.
Well, I'm not sure if you misunderstood some kind of things, because we have no IP addresses. We have user IDs, and these are unique user IDs which were provided by AOL, which substituted the AOL screen name. So they actually had the username. They are logging it for some reasons. I don't know why, and so they just substituted this with an anonymous, unique number. So we can say that these are actually real users. Okay. Thank you.